Hello, I'm HomoArrosor. We are standing right in the middle of July 2026, and today I'm walking you through what is arguably the most massive paradigm shift in the entire history of human labor. Think about it. Physical work, the very thing we've done for millennia, the sweat on our brows, the calluses on our hands, is officially transitioning into a digital behavioral asset. We're moving away from a world where humans just sweat and execute tasks. We're moving into a world where we, as everyday people, are actually building the behavioral data engines that will power an entirely new robotic economy. In this explainer, we're going to look incredibly closely at Axis Robotics and exactly how human intelligence, physical robotics, and decentralized networks are coming together to form a completely new closed-loop production cycle. It's a fascinating shift, and it completely redefines what it means to work.
So, let's really unpack this core idea first. Human labor is no longer about execution. In this new era of physical AI, we simply don't do the heavy lifting anymore. Instead, we become the teachers. Think about the unconscious, implicit knowledge you have right now. How do you grab a coffee mug without dropping it? Or how do you reflexively adjust your grip when that mug suddenly slips? You don't even think about it, right? But that instinct is now literally the most valuable asset in the digital world. Labor is no longer about physical exertion. It has evolved into a highly advanced educational process where human cognitive and physical judgment is extracted, captured, and transformed into a behavioral trajectory. You aren't just moving an object, you are creating a map of human intuition.
Section 1. The $12 million Access Investment, Financing the Physical AI Data Engine.
All right, let's look at the catalyst for all of this. On July 27, 2026, a company called Axis Robotics announced a massive $12 million seed round. Now, this round was led by Hack VC, but here is the crucial part. It included the direct, strategic participation of Pi Network Ventures. Securing $12 million for an early-stage startup, we're talking a tiny team of just 11 to 50 employees, is absolutely staggering. To put that into perspective, in today's market, a seed round of that size comfortably signals a valuation pushing somewhere between $50 and $80 million. This capital injection is the spark. But they aren't just funding another hardware company making metal arms. No, they are financing the massive behavioral data layer that this entire industry so desperately needs to move forward.
You see, you have to understand the difference here. Axis does not build robots. They aren't in the business of manufacturing metal shells or machining joints or soldering wires. Instead, they are building the behavioral data factory that actually gives those metal shells a brain. They are creating the cross-machine infrastructure that educates the hardware. It's the vital experiential intelligence that takes a very expensive, very heavy piece of machinery and turns it into a functional, autonomous agent capable of navigating the real world.
Section 2. The Physical AI Bottleneck. Why internet data is insufficient.
So why do we need this massive data factory? Well, it comes down to a fundamental bottleneck. You know those large language models, the text-based AI we use every day? They got incredibly smart by scraping billions of internet documents, articles, and conversations. But robots? Robots have to operate in physical reality. They require spatial logic, physics, and movement data. And here is the harsh truth. That kind of data simply does not exist on the web. You can show a robot a million JPEGs of a coffee cup. You can have it read the entire Wikipedia page on ceramics. But none of that will stop the robot from crushing a real, physical cup into dust the second it tries to pick it up. They require entirely new, physical datasets that the traditional text-based internet just cannot provide.
Let's drill down into what that data actually looks like, because the continuous stream of information required for a robot to perform even a simple physical task is staggering. We aren't talking about words on a page. The robot needs joint angles and positions measured over incredibly precise intervals of time. It needs real-time movement speed and acceleration. It requires exact object orientation, spatial coordinates, multi-angle camera perspectives, and crucially, real-time success or failure metadata. A robot needs this massive, continuous river of data just to figure out how to pick up a mug from a table without knocking it over. And right now, only humans can generate this continuous physical logic.
Section 3. Assetizing human behavior, from action to trajectory.
This brings us to exactly how Axis captures this data. They've built a 4-step pipeline, and it's brilliant in its accessibility. Step 1, you literally just open a web browser. There are no million-dollar motion capture rigs required here. You control a virtual arm using a standard computer mouse within a simulation environment called Mujoko to perform a specific task. Step 2, the Axis software steps in, automatically refining your human input and removing any jitters. Step 3, a system called Isaac Sim takes that one single perfected data point and amplifies it exponentially. And finally, Step 4, that data is deployed as model-agnostic training material. It is an incredibly efficient, highly scalable pipeline for capturing everyday human intelligence.
What we are talking about here is something called behavior trajectory assetization. Remember that human implicit knowledge we talked about? The exact, delicate pressure you need to hold a paper cup without denting it? That knowledge is literally extracted from you. Your physical movement is transformed from a continuous physical demonstration into a unique digital asset on the blockchain. It becomes a universally applied training data set. The very action itself is tokenized, stored, and ready for deployment. Your intuition literally becomes a digital asset.
But here's the catch. Humans are not perfectly precise machines. We shake, we hesitate, we sneeze. When a human operator controls a mouse, the raw data is full of microtremors, weird pauses, and erratic accelerations. Axis mathematically filters out all this human jitter. The software specifically removes failure trajectories, it eliminates stationary periods where you just stopped moving, it filters out excessive shaking, and it resamples the timing so the robot learns a perfectly smooth execution. In fact, raw data from humans actually decreases simulation success rates. It is this highly specific mathematical data engineering that takes our messy human input and turns it into perfect execution.
Section 4. Simulation and continuous correction, amplifying the asset.
Now, a robot can't just learn from one perfect example. It needs to know how to succeed in chaotic, real-world environments. So that one single, smoothed-out human action is mathematically multiplied into thousands of different scenarios using domain randomization and Isaac Sim. The system automatically takes your demonstration and alters the camera angles and lighting. It changes the object's colors and textures. It even modifies the physical friction coefficients on the virtual table, injects calculated sensor noise, and shifts the robot's starting position. So your one single demonstration of picking up a cup explodes into millions of unique environmental variables, thoroughly teaching the robot how to succeed under literally any condition.
And even with all that simulation, the real world is still unpredictable. This is where the V2 continuous human correction loop comes in, proving that humans aren't just the starting line. We are the continuous correctors. Here is how it works. A trained model is deployed into the real world. Inevitably, the robot encounters a weird edge case and fails a task. That failure is instantly detected and sent back to a human operator. The human then intervenes, physically corrects the trajectory right from the point of failure, and the model is rapidly retrained with this highly specific correction data before being immediately redeployed. It is a true, endlessly scalable post-training loop.
If you are wondering if this actually works outside of theory, the hard data is already here. A research preprint published on July 23, 2026 proves the effectiveness of this loop. The data output from this process yielded 207 unique operations, generating over 50,000 refined trajectory assets. And the results? When this Axis data was applied to Physical Intelligence's Advanced Vision Language Action Model, which is named Pi 0.5, and just as a quick side note, the Pi here is just the model's name and completely unrelated to the Pi network, it created a staggering 5.8 percentage point performance boost. Now, in the world of advanced AI models, a nearly 6% jump in success rate isn't just a bump, it is absolutely massive. It definitively proves the immense value of Axis's human-generated data.
Section 5. OpenMind and Axis Synergy, delineating the physical AI ecosystem.
To really grasp the bigger picture, we have to look at how this ecosystem delineates responsibilities. There is a very strict, clear boundary between two major powerhouses here, OpenMind and Axis. OpenMind is the execution and operational layer. It manages the hardware abstraction, the decentralized computing, and the overall robot economy. Think of OpenMind as the Android operating system of robotics. It runs the hardware. Axis, on the other hand, is strictly the behavioral data layer. It handles the human demonstrations, the simulations, and the model training. In short, Axis is the educational factory that teaches the brain long before that brain ever hits the OpenMind operating system.
And the genius of Axis is that the data it produces is model agnostic. This means the behavioral data is not bound to a single AI model or one specific robot body. It is universally valuable. Because the behavior is separated from the hardware, you could train a behavior today on a stationary robotic arm in a warehouse,
and deploy that exact same physical knowledge tomorrow on a quadruped robotic dog navigating a forest. The knowledge translates perfectly across entirely different hardware platforms because the behavioral data is formatted to a universal standard.
Section 6. Returning value to humans. The Pi ecosystem production loop.
So how does all of this tie into the Pi network ecosystem? It forms a perfectly closed, incredibly efficient production loop. Let's walk through it. Step 1. Pi KYC verified humans sit at their browsers and provide the initial behavior data. Step 2. Access takes over, assetizing that browser demonstration into a refined mathematical trajectory. Step 3. The massive computational power required to simulate those millions of environmental variables is processed globally by Pi nodes. Step 4. OpenMind takes that perfectly trained model and executes it on physical hardware out in the real world. And finally, Step 5. Pi token rewards are distributed directly back to the verified humans who provided the data and the node operators who provided the computation.
You can clearly see why this ecosystem absolutely demands Pi Network's unique infrastructure. In the AI era, data poisoning by bots is literally fatal to a model. Pi's rigorous KYC ensures that verified humans, and strictly not bots, are the ones generating these massive amounts of clean, authentic behavioral data. When you combine that global, verified user base with the top 100 Pi node apps computing those intense simulations, and then use the Pi wallet to flawlessly handle global, borderless micropayment distributions, you have a perfect strategic fit that Axis simply cannot find anywhere else in the world.
Section 7. The paradigm shift in labor, from physical execution to digital guidance.
We are witnessing a total redefinition of what it means to contribute to AI. Past AI labor was frankly pretty menial. It meant humans acting as basic categorizers, spending hours drawing tedious bounding boxes around static JPEGs and labeling pictures of traffic lights and cats. But the future of physical AI labor, it is infinitely more valuable and complex. Humans act as high-level behavioral teachers. We act as continuous correctors, swooping in to fix physical edge cases that baffle the machines. We act as decentralized node operators powering massive robotic fleets. It is a highly elevated, dynamic, digital role that relies on our unique human intuition.
I want to leave you with this final, definitive reality. The ultimate architecture of physical AI ensures that the economic value of robotic labor returns directly to the humans who teach them and compute their minds. Human physical labor, the execution of heavy lifting as we know it, might very well be fading away. But our human experience, our implicit knowledge, and our intuition will be immortalized and financially rewarded on the blockchain. The only question left is, are you ready for your everyday movements to awaken the minds of machines?